What are parametric equations? To understand that, what we need to understand first of all is something known as Cartesian equations. Now, up to now, what we have generally seen is equations of the type y equals f of x. We've got y equals some function of x. Yeah. Now, that is known as a Cartesian equation. So, for example, you might have had y equals x squared. This is a Cartesian equation. They're directly related, and there's nothing else between those two variables. And if you wanted to sketch it, you would have had x, y, and maybe you would have a table of values on the -2, -1, 0, 1, 2, get some y values from using that equation. So we're going to take the x value and we are going to square it. So we've got 4, 1, 0, 1, 4. And that then gives us how x and y are related. And this is known as a Cartesian equation. And we get a quadratic that looks like that. Now, parametric equations have an additional parameter, have a third linking variable. So, for example, you might have x equals sine theta and y equals cos theta. Okay, so now we can see that actually x and y are not directly related to each other in this case, but they are linked through some third parameter theta. Or you might have x equals 40 and y equals 70 squared. And again, you've got a third parameter. You've got x, y, and a different parameter that links everything together. In this case, how might we go about sketching or trying to understand the relationship? Well, for number 1, you might have theta, x, and y values. So you might have theta values, I don't know, 0, pi over 8, pi over 4, whatever, 3 pi over 8, and pi over 2. And then you would substitute all of these into x and y to get your values. So x now, sine of 0 is 0, sine of, oh, I should have picked better numbers. I'm going to do that now, because then we can get exact values. Pi over 6, pi over 3, and let's say pi over 2. Now, if I substitute these theta values into x, sine of pi over 6, can you please tell me what is sine of pi over 6? In the chat. Right, okay, so yeah. So now when you put your calculator into radian mode and type that in, you get a half. Sine of pi over 3 is going to be root 3 over 2. Sine of pi over 2 is 1. And now if I think about y we get by doing cos of theta, and we know theta values. What's cos of 0? 1. Cos of pi over 6, root 3 over 2. Cos of pi over 3, a half, and cos of pi over 2 is 0. So now if I was to sketch this, I've still got x and y values. When x equals 0, y equals 1. When x equals a half, y equals √3/2. So, I don't know, let's say a half is here. And when it's √3/2, we get a half. And when it's 1, we get y value 0. So we get some sort of curvature that looks like that. Okay, so does that make sense how a parametric equation is different to a Cartesian equation? Can you see that there is a third variable? We're going to keep different values for that variable and substitute that variable into x and y to get x and y coordinates. Once we've got x and y coordinates, then we can plot them to get an understanding. And there are other techniques that we are going to learn to get the equation of the curve as well. And again, we've got x equals 4t and y equals 7t squared. So for example, there, if we look at example 2, x equals 4t, y equals 7t squared. I've got a third parameter, which is t. Now I might say -2, -1, 0, 1, 2. And based on those, I'm going to get my x coordinates. So x is 4 times by -2. -8, -4, 0, 4, 8. Y coordinates, I'm going to do 7 times by t squared. So -2 squared is 4, times by 7 is 28. -1 squared is 1, times by 7 is 7. 0 squared is 0, times by 7 is still 0. 7, 28. So now I have got x and y values. When I had a x coordinate of -8, had a y value of 28. -4, it was 7, 0. And then again at 4, I've got this, and at 8, I've got this. So it's looking a bit like a quadratic. And we're going to come to check that out in a bit and understand that. Right, okay. Well, let's now actually look at an example to understand how questions on this topic are actually laid out and what this means. Right, okay. Firstly, before we go too deep into that, I want to understand your understanding of domain and range. What is domain? What does domain mean, and what does range mean? Domain refers to allowable x values, and range refers to y values. Or in other words, this is like your input and this is your output. Okay. Now, one important thing over here is we're going to learn about this, right? So a curve has parametric equations, and we've got x equals 2t and y equals t squared. We're told that t can only range between 3 and -3. Now part A, the question is saying find a Cartesian equation in the form of y equals f of x. That means we need to eliminate t. There can't be a t in this equation. We just want a formula in terms of x and y, where y is the subject of the formula. Right. One strategy you could do here is to say, well, make t the subject in either equation. It's easier to make it the equation in a linear equation. So we're going to say x over 2 equals t. And then once we've worked out what t is, we can substitute that back into the remaining equation. So y equals t squared is going to become x over 2 squared. So what we end up getting is y equals x squared over 4. So what this is telling us is that this parametric equation, because at this stage it was parametric, is the same as this Cartesian equation. We've eliminated the third parameter, and we've got just an equation in terms of x and y. Does that make sense? Can you please let me know with a yes or no? Right, okay. So we understand that, and that's cool. Now, part B, we have been asked to state the domain and range of f of x. Right, this is very important. I see initially some students get confused with this, so I'm just going to take my time explaining it. When we're looking at domain, we are going to use the formula for x. We are going to use the formula x equals 2t. And we are going to use the restriction on t to help us work this out. So I'm going to write that underneath here. So what do I do with this? We're going to treat this as y equals 2x. Okay. But we are going to label the y-axis x, and we're going to label the x-axis t. Now, we are going to sketch y equals 2x, where x lies between -3 and 3. So that is going to be a straight line, because y equals 2x is a straight line that goes through the origin. When t equals 3, your x value would have been 6. And when t equals -3, your x value would have been -6. Are you happy with that? Does that make sense? Please, can you let me know in the chat? Any confusion here? Right. Now, when we're looking at domain, we said allowable x values. We want x values. And x is on the y-axis in this case. So the allowable x values, the lowest allowable x value is -6. And the greatest allowable x value is 6. So what we can say about the domain is that x is less than 6 but greater than -6. And here is our domain. This is our domain. Okay, does that make sense? When we are talking about the domain, we said earlier at the top of this sheet that domain refers to x values. In this case, x is on the y-axis, and so we only look at the height of this straight line. What is the minimum height? It's -6. maximum height is 6, therefore x values lie between -6 and 6. Now, if for domain we are sketching that, what are we going to sketch for the range? Please type that in the chat. If for domain we sketched x equals 2t, what are we going to sketch for the range? For the domain we did x equals 2t. For the range we are going to do y equals t squared. And t still lies between -3 and 3. And again, just to draw a comparison, what are we going to do? We are going to say y equals x squared. And this is like saying x lies between -3 and 3. So y equals x squared. We know what that looks like. It looks like that. At -3, we get a y value of 9. At +3, we get a y value of 9. Now, looking at this graph, can you please tell me your range? So this is y and this is actually t. What is your range here? The lowest height that y can take is 0. And the greatest height y can take is 9. And so we can say y is greater than 0 and less than 9. And it has to be in that order, obviously, because 9 is bigger than 0. Does that make sense? Right. The question is, won't it be less than or equal to or greater than or equal to? Actually, one of them, 0 is equal to, thank you for pointing that out, but not 9. Because at 3, it is 9, but we said t is slightly less than 3, so it doesn't quite reach 9. At -3, it is 9, but we said t is slightly greater than -3, so it won't quite reach 9. But 0 is part of that range, so 0 is included, and that's why y is greater than or equal to 0. In fact, put this down. This is, again, an area where a lot of mistakes are made. Okay, does that make sense? Now, yeah, I would definitely recommend sketching x against t to work out domain, sketching y against t to discover your range, to work it out for parametric equations. This is the best way of doing it. This always helps you avoid any other mistakes you might make on here. And again, we look at special cases as we work through this chapter. Now, part C is telling us to sketch the curve within the given domain for t. So we are told what t is, and when t lies between those values, x lies between -6 and 6. And we know that y equals x squared over 4. So we now need to sketch between -6 and 6 on the x-axis our y values. Well, that's a quadratic with a stretch of a scale factor 1/4 in the y. When x equals -6, you're going to get 36. Divide that by 4, I get 9. So this height here is 9. And then when this is 6, we again get 9. And we end up getting a quadratic that looks like that. And there is the sketch of y against x for the given domain for t. Does that make sense? Are you happy with that? So in this question, we're told that x equals ln t plus 3, and we've got y equals 1 over t plus 5. Now, I want to make y the subject, so ideally I want to be replacing this t with something else, because then y has already been the subject. And that then makes me think I want to make t the subject in x, but this has got an ln in there. So how are we going to make t the subject for this? Well, let's not forget that this is the same as saying log base e t plus 3 equals x. So that then means e to the power of the right hand side equals the bracket. And from there we can make t the subject very easily. We can say e to the x minus 3 equals t. Does that make sense? Are you happy with that? And you might have got there a step sooner if you didn't write like this as well. If you can just straight away think, if x equals ln y plus 7, for example, you can just say e to the x equals y plus 7. You can get to that in one stage now. You don't always have to write this log base e. That's just for your understanding, so you can see the link. Now, once we've got that, then from there, it's very simple what we need to do. So we know what t is equal to, so we can now do the substitution on the right hand side. So 1 over e to the x minus 3 plus 5, which ends up becoming 1 over e to the x plus 2. And there is the Cartesian equation. We haven't come to the domain yet. X is greater than k is the domain, but we'll come to that in a second. Firstly, does the Cartesian equation make sense? Are you happy with that? Can you please let me know in the chat? And like I was saying, each one will have a new strategy for the first few times. So here we had to take exponentials to get rid of the log form. Right, okay. I now want you to work out the domain for this, for these parametric equations. So we said to work out the domain, we are going to sketch x against t. That's the important bit. Okay, so domain, I want you to internalize this. X against t. So we know what the formula is, x equals ln t plus 3. Now, we might not be able to do that straight away. I might do that in 2 steps. So first I'm going to sketch x equals ln t. Now ln t, if this is t and this is x, ln t looks like this. I just need to write down t is greater than minus 2. X against ln t looks like this, and then we've got asymptote at t equals 0. Now that then is going to help us sketch x equals ln t plus 3, because that allows us to transform this graph and shift it 3 to the left. So if I shift it 3 to the left, my asymptote is going to go to t equals minus 3. And this is minus 2. And this is x and this is y. Are you happy with the sketch of x equals ln t plus 3? Now then we are going to look at this condition on t. T has to be greater than minus 2. So that means we can only have this bit of the curve. And like I said before, we want the height of x. So that's the lowest height, and it keeps going up forever in that direction. Well, the lowest height there has a value of 0. So what we can say is that x is greater than 0. And there we have it. That is our domain. Therefore, k equals 0. Let me know if you don't understand any particular bit in there, so that I can help you spot that. So we now need to sketch y equals 1 over t plus 5, where t is greater than minus 2, sorry. So we now need to sketch this. Now, does that remind you of anything? Does y equals 1 over t plus 5 remind you of the type of graph you need to be sketching? It should be a reciprocal graph. You should be thinking y equals 1 over t. That's my starting point. I look at the base graph. This is sort of like the base graph, which I'm then going to transform to the graph that I want. We know what 1 over t looks like. Here's y, here's t. 1 over t looks like that. But now I need to somehow transform it to this graph. What transformation has taken place from the base graph to the graph that we want? I want you to type that answer to that question in the chat. What transformation is going to take me from the base graph to what we want? If it's t plus 5, if I replace all of t with all of t plus 5, it's shifted left by 5. Yeah, if it was plus 5 outside the fraction, then it would be shift up. But if all of t has been replaced with t plus 5, it's shift left by 5. So now I'm going to have a graph that looks, oops, that's so bad, like this and like that. And then this asymptote here is t equals -5, and we've got y equals 0 as an asymptote there as well. Are you happy with this graph for 1 over t plus 5? Does that make sense? Please let me know in the chat. Okay, so now you're also understanding how to go about sketching graphs. You go to a base graph and then you transform it. It's always going to be in that step. If there's more than one transformation, then you need to do more than one transformation. Each one requires its own graph. Now we said t has to be greater than -2. So here is -2 on the t-axis. And when we sub that in, we get a height of 1 over 3. That makes sense, yeah. Without the base step, it's difficult to see the transformation. So when t equals -2, we get a y value of 1/3. But we said we can only allow t values greater than -2. So therefore, we can only allow this part of the graph. So therefore, what are the allowable heights? Well, the maximum it could be is at 1/3, and the minimum it could be is just above 0. Sorry, this should be 1/3, and this is 0. So what we can say here is y is greater than 0, but less than 1/3. And there is your range. Does that make sense? Can you please let me know in the chat if you are happy with that? Or if you're not happy with it, also let me know so that I can help you understand. So in this, we are given that x equals t minus 2 and y equals t squared plus 1. Now, it's quite easy to make t the subject in the linear one. X plus 2 equals t. And then we can say, well, t squared is going to be x plus 2 squared plus 1. Okay, and there we have it. In the form of y equals f of x. We didn't need to simplify it. We could have done, and we could have got x squared plus 4x plus 4 plus 1, which gives us this. So either of those two answers is fine. Now, for the domain, we said that we would sketch x against t. X equals t minus 2, and t ranges between 4 and -4 inclusive. So here's t, and here is x. When t equals -4, x equals -4 minus 2 is -6. So here's -4. And this is going to be -6 somewhere down here. And when it equals 4, 4 minus 2 is 2. And it's obviously a straight line. It's equation a straight line with the y-intercept of -2. Now, we said we want the domain which would be represented by the height on this graph. So the lowest height is -6 and the highest height is +2. So now x, we're going to say, sorry, -6 should be on that side and 2 should be on the right hand side. But notice that this has got equal to. So x can be equal to those values. Okay, that's very important. So there's our domain. Does that make sense? Any questions there? Right, okay. Now let's have a look at the range. So for the range, we are going to sketch y against t, and y was t squared plus 1. And that is going to be between -4 and 4. So at -4, -4 squared is 16 plus 1 is 17. So I get, this is y and this is t, I'm going to get 17. It's essentially a t squared graph shifted up by 1. So I can now sketch that. And 4 will have the same value of 17 as well. Are you happy with that? With that graph for y equals t squared plus 1. Now, if I think about the lowest height on this graph, it's actually 1. And the highest height on this graph is 17. And both of them are allowable because t values include those, are included in those. So therefore, we can say y is greater than or equal to 1, but less than or equal to 17. Does that make sense? Please let me know in the chat if you are happy with that.